Swish, swoosh, bang to bang, and I'm working on my body like a chimpanzee. Zang, I the only player with the big prize, I the only player with the big brown eyes. Roll like a train in the middle of the block. You better call the cops, I'm playing on the clock. Yo, swag, swag, working on my swag. Venom in the booty, and I got my gas. Yeah, wham, bam, super tramp. And I tipping up my hat while I boost the fans. And I hover up top, can you feel the noise? All the girls scream now cause they want the boys. Yo, banging on the clouds looking like a big joke. When I run so fast and I sing so low. And you never wanna mess with me, you just listen me. I just set me free, so just stop. We cool, we hot, we freshin'. We know we all messin'. My bling bling catch your eye. Better pull up those shades when I walk you by. So give a big high five on the street. Next time I wanna fly by, feel the heat. Cause I'm on the roll, I lose control. Want you to know it's how it goes.
Alright guys, so again, that was just a little fun video to get your mind off math for a minute, because everybody needs a little break. But alright, we are back to some awesome Keystone stuff right here. Okay. Again, if you have any questions about any of this stuff, I would highly recommend maybe off to the side, jotting down a little note here and there saying like ask Mrs. Long or Mr. Howard, about this question. It'll help you out big time. Okay. Number 25. Mike discovered that the pool in his backyard is leaking slowly. The pool holds 19,208 gallons of water and is leaking at a rate of 17 gallons per day. If Mike does not replace the water that has leaked from the pool, how many gallons of water will remain in the pool after 36 days? Before you solve the problem, explain why choices B and C can be easily eliminated. Alright, let's take a look here. We had 19,208 gallons of water in this pool. So why could we get rid of B and C? Okay. Well, check out. B says 19,244, 19,820. Isn't that more water than what was in the pool? Okay. So B and C have, let me get rid of this little thingy over here, have more water, which makes no sense since the pool is leaking. Okay. One of your greatest assets when you take this test is the idea of common sense. Alright? Here's the other beauty of this. When you first looked at this problem, you had a 25% chance of guessing a correct answer. Alright? I mean, honestly, if you had no idea, you could just go, that one. Okay? But by eliminating two of these answers, now you have a 50% chance, which you've literally doubled your chances of being correct. So it starts with, we'll call this y equals 19,208 minus 17x. Okay, where x is the number of days, y is the number of gallons that are left in the pool. So, good old calculator. You want to know after 36 days, we'll plug 36 in here. Okay, 19,208 minus 17 times 36. So we got 18,596. Boom. Okay. You could sit there and go minus 17, minus 17, minus 17. But that's going to be annoying and you're going to burn yourself out doing that. Just set yourself up an equation. You'll be in good shape. Alright. Forest Lumber uses the function S of t equals negative 105t plus 525 to determine the salvage value S of t in dollars on a table saw t years after its purchase. How long will it take the saw to depreciate completely? Alright. Now here's the thing, this is actually a really interesting problem for not only a saw, okay, table saw, but also for a vehicle, a car. Hopefully you all want to drive a car someday. Someday I'm going to get my Camaro. Don't worry, it's on the way. It's coming soon. But every time you have initial cost, okay, so in this problem, just to take a look at it, the 525 bucks stands for how much this table saw originally cost. Every year, it loses 105 bucks, meaning the value of it drops $105. The same thing works for a car. Now when it says depreciate completely, that means how much does it take for the value of it to go down to 0. Alright? So I can plug a 0 in here. Okay, and now all I gotta do is solve for it. I can add 105t over. I can divide both sides by 105. We get 5. So 5 years. But you could, just subtract 105 over and over again. That problem's not too bad because there's only so many numbers. But when it says depreciate completely, you are thinking about just going to 0. That's all. Okay? In the equation from problem number 2, I think that's number 26, what do the negative 105 and 525 represent in the context of the problem? How much money is lost each year is the negative 105, and this represents initial cost. Again, I know we went over this in class the other day, but a lot of the keystone is just telling you what the problem is about. So it's not just solve for x, solve for t, solve for whatever now. It's like read the problem, understand what it's asking. Okay, there's Thor right there, by the way. He's saying hello. And there's Iron Man. There's Captain America. Who else we got on here? I think Hulk's in the top part. Oh, there's Hawkeye. I think Hulk's covered up right here. Hulk smash. All right. So number 28. Erica went shopping for new clothes for school. She bought a pair of jeans for $68.88 and several shirts for $10.74 each. If X represents the number of shirts she bought, which of the following equation should you use to find Y, the total cost of Erica's trip? All right. She bought one pair of jeans, $68.88, and she also bought shirts for $10.74 each. But X represents the number of shirts she spent. So basically, this is what we're looking at. Which one over here does that? Okay. This one right here, again, you have the X equals. It's not what we want. We want Y equals for our total cost. You can get rid of that right away. So we're down to these two, but each shirt costs $10.74. Each shirt does not cost $68.88. That would be a lot of money. So there we go. Again, very easy to kind of mix things up. I know I mentioned this before too, but during this exam, you have as much time as you want. So take your time, meaning don't rush through the problem. Okay. So just a heads up there. All right, on to the back. Keep on rolling. You are driving home to the football stadium. After driving 12 miles, you begin to record your distance driven D in miles after M minutes. The results are in the table below. 0, 12, 5, 15, 10, 18, 15, 21. The pattern can tell you so you ride home. Write an equation to find the distance traveled D in miles after a given number of minutes M. Now, what they're saying here is this is your Y, this is your X. I know everybody panics when they see, the various little things here, okay? Just be careful about that. But, all right, so what we need for writing an equation of a line is two things. We need slope, and you need y-intercept. Well, luckily for us, we are going to be given the slope formula. And it will be on our formula sheet. These are all points. X1, y1, x2, y2. So if I plug this in up here, 15 minus 12 over 5 minus 0, we get 3 over 5. Alright? So now I have a slope. Well, I also have y equals mx plus b. I still need my b, because slope is my m, y-intercept is my b. So pick any point you want. Again, I'm going to pick, well actually we're kind of lucky here, I'll see why in a minute. Here's a point 0, 12. Put a 12 in for y. Put 3/5 in for my m. Put a 0 in for x. And for my b, we're going to put just b. What's 0 times 3/5? Yay, 0. So b equals 12. Once you have an m and a b, plug it back into here. Just leave your y and your x the same. Y equals 3/5 x plus 12. Alright, now we're so close to being done. I know this is being nitpicky, but I'm just trying to help you guys out. You know how down here we said this is y, this is x? Plug them back in, meaning instead of y, put in d, and instead of x, put in m. This is the way I used to do it because I'm just a big fan of y and x. Call me an old-fashioned kind of guy, but it's just what we're used to. But they are going to ask you for different letters on this test. You may do this, and I've done it myself. You just replace it. and it helps you out greatly. Okay, I think we got time for one more. You also keep track on the remaining gasoline. The equation below can be used to find the gallons of gasoline remaining G based on distance from home D in miles. Record in the table below the number of gallons of gasoline remaining after driving D miles. All I'm going to do is plug things into this formula. Well, good news, everyone. I have this calculator, nifty, and all I'm going to do is 15, where am I getting this from? Right here, minus, put parentheses, 1 over 15. Okay, and then for my D, I'm going to put in 24. Now, if you are lazy like me, hit enter. Okay, so 13.4, sweet. So 13.4. I can hit second. Just check this out for a minute. Second, enter. And that brings up the last line that you just did. So I can hit the left arrow key to cover the 24 and replace the 24 with 27 because I don't want to retype it. Yeah, I know I'm lazy. 13.2. And then I can do the same thing. 30. 13. Quick question for you. Does this make sense that the more distance you travel, the more your gasoline drops? I'm hoping that everyone is nodding your head right now and going, yes, Mr. Howard, you're the best teacher in the entire world. Man, I love math. Oh, sorry, I was just talking to myself. But yeah, hopefully that makes sense to you that as you're driving, your gasoline will go down. Okay, it shouldn't go up. So if for some reason you're plugging this in here and it's going up, maybe double check your work. Maybe you accidentally put a plus sign here. Okay. Again, nothing would make me happier than for everybody in this room to become self-sufficient, meaning that you guys can think for yourselves about mistakes you're going to make. Because guess what? No one's perfect. You're going to make mistakes, but it's how you recover from those mistakes that mean the most. Okay. So hopefully this video helped a little bit. There's more to come. All right. Take your time again. If you need a little break between videos, totally cool. Write down questions as you go. All right. We'll pull you all back together again and talk about this at the end of the week or possibly next week. But make sure you guys remember, good luck. We're all counting on you.